All right. Hello, everybody. My name is Minko. I'm an engineer in the Angular team at Google. In this presentation today, I want to give you an overview on what to expect from Angular Ivy in the next 6 to 12 months. To make sure that we are all on the same page and to see how much more awesome Ivy is going to be, I want to start by talking about the present. I want to start talking about the current compilation and rendering pipeline called ViewEngine. Once we set the context, we're going to talk about the future, Ivy. Once you see how different these technologies are actually under the hood in terms of implementation, we're going to discuss the transition, which for you should be seamless. So our big goal for version 9 is to enable Ivy for all the Angular applications out there. Ivy is this project that we have been working on for about 2 years now. We have been talking about it on a lot of conferences, and what has been stopping us to release it is mostly to keep everything backwards compatible. So Ivy aims to make the framework simpler, smaller, faster, and of course, backwards compatible. Now let's talk about why Ivy is going to make Angular simpler. First, how does Angular work today so that you can appreciate the simplicity coming from Angular? Ivy. You have your Angular component, app.component, app component in this case, and most likely, internally, Angular CLI is going to pass it to ngc, which is the Angular compiler. Out of this single file, we're going to generate 5 different files. An ngfactory, metadata file, component.js, component.ts, and of course, an ngsummary. We're going to stop on these files that you probably care about. So, ngfactory first. It is produced by the component metadata as some global knowledge about the application so that we can compile its template into the right context. It instantiates the controller of your component, this ngfactory file, as well as it takes care of some rendering and change detection. It is important that if you're building a library and shipping it on NPM, you probably don't want to push this file as well because we're going to override and generate on top of it anyway. The metadata file is used primarily for static analysis. So it contains some metadata for your components, such as its selector, view encapsulation, change detection strategy, and much more. It is used by our language service so that we can provide you some auto-completion and type checking in templates. It is used by other third-party editors such as WebStorm, and we're also using it for template compilation. We are recommending you to distribute this in your NPM library so that your users can use ahead-of-time compilation and take advantage of the different features that we provide with our language service. The component JS and DTS, these are the most intuitive ones. Of course, the JS file provides the JavaScript logic for your components, and the DTS file provides the type definitions. You must distribute this on NPM if you're a library author. So with Ivy, you have, again, your app component. You're going to pass it to ngc again, but this time you're going to get only 2 files out of it, the JS and the DTS file. The JS file, in this particular case, is going to contain the component definition. It is going to take care of instantiation, rendering, and change detection. The DTS file is going to contain not only the type definitions, but also some metadata for your component so that we can take advantage of the same ahead-of-time compilation as well as language service support. Eventually, at some point, our recommendation is going to be to distribute this on NPM, but not just yet. Follow me in the next couple of slides to understand why. So here is why the JS file is completely enough. To your component, we're going to add the static methods factory and components, which will take care of creating the component by passing the requested dependencies by the dependency injection mechanism. And the component definition is going to contain a function that is going to render your template and perform change detection. Now, you can see that both of these rendering and compilation pipelines are completely different under the hood. So you might be wondering how we make them play together. Well, here we're going to talk about backwards compatibility. In fact, if we relax this condition, if it wasn't a primary goal for us to keep everything backwards compatible, we'll have been able to release Ivy maybe a year ago or so. As you probably know, we have about 1,500 Angular applications inside of Google, and only the UI of Google Cloud Console is 3 million lines of code. So it's pretty big. We started migrating all our internal repos, all our internal projects to Ivy a lot of months ago. We discovered a lot of issues. We fixed them into the framework so that we can make sure that your transition is seamless. But still, during RCs, we're discovering new such issues and fixing them along the way. So I want to tell you a story from like maybe 2 weeks ago. I was on Angular meetup in San Francisco. And usually when I see a group of people, it doesn't matter whether it's an Angular meetup or just hanging around in the park or in the aqua park or a family gathering, I just go to people and ask them, how is your Angular migration experience? And I found a person from Crunchbase, one of their lead developers. I asked him, how was your Angular migration experience? How was your migration to version 8? And he said, oh, cool, it was pretty smooth. But now we tried the RC of version 9. And like my heart started beating. Because I know how many issues we were resolving in all of these internal projects just like days before I asked him. He said, well, I just ran ng update and everything worked. I was really nicely surprised because his application is probably several hundreds of thousands of lines of code, so it is considered a big one. And it seems that our migration experience that we were intending worked for him pretty well. Still, we have a couple of more RCs until we release Angular version 9 in the beginning of December. But what we're planning to allow you is to just run ng update, Angular/core, Angular/CLI, and this should update all of your Angular dependencies. It should update the build system and use the Ivy compiler instead of the Vue engine compiler. It should execute all the migrations, which are about 5. And should make all the libraries that you're using Ivy compatible. So this is probably the hardest thing, because you saw how much different the code produced by Vue engine is compared to what we have in Ivy. Here is how everything is going to work once you're using a Vue engine library with your Ivy application. We're going to compile your Angular application with ngC, and we're going to produce a bunch of JavaScript. In the same time, since your library has already been compiled to Vue engine, so you have the metadata files and the factories, we're going to compile this with another compiler called ngcc, the Angular Compatibility compiler. Once we have these two outputs, they're going to be completely Ivy compatible, so we're just going to link them together and optimize them so we can take advantage of everything, all the benefits that Ivy is going to provide. So currently, we all have Vue engine libraries on NPM, right? And that's how it is supposed to be, until we decide to encourage you to publish Ivy source code there. And at some point, we're hoping that all the libraries on NPM are going to be Ivy compatible. Until then, we have Vue engine applications talking to Vue engine libraries. We're going to use ngcc at some point, once you switch some of your Vue engine applications to Ivy, to consume the Vue engine libraries. More and more of your applications are going to move to Ivy, and eventually we're going to use ngcc only as a backup for some dead libraries that are no longer maintained. To make sure that we're working properly with most Vue engine libraries, or at least with a popular subset of them, we built the ngcc validation repo, where we have a CI on top of many popular libraries. So every time, once we push new code to master on GitHub in Angular, we're running our CI against all of the libraries in this validation repo to make sure that they successfully compile with ngcc, so they are successfully compatible with Ivy, as well as we run a bunch of end-to-end tests with them to make sure that they're working properly at runtime. Currently, we have over 160 libraries. Our build takes about 15 minutes, and 94% of them are compatible. To my surprise, most of the failures weren't from ngcc. They were from these libraries using just very old deprecated APIs, using render instead of renderer2, an API that we deprecated over a year and a half ago. Although this is not an Ivy problem, we work very closely with the library authors. I, in fact, tracked some of them down. I found some in the social media so that they can publish the pull request that I send them.
So if you don't migrate your Angular library, I'm going to track you down. I'm going to open a pull request, and after that, ask you to publish it. And we have 94% compatibility, with some of the failures are coming from libraries, library authors who were not responsive, unfortunately, and we weren't able to push our fix in there. So our transition right now, our plan for incremental adoption of NGCC and transition from Vue Engine libraries to Ivy in the next year and a half is first to encourage everyone to switch to Ivy in version 9 and continue shipping their libraries as Vue Engine code on NPM. Right after that, in version 10, once we finalize the instruction set of Ivy, we're going to start encouraging you to publish Ivy source code on NPM. And eventually, we're going to use NGCC only as a backup for libraries of others who we weren't able to track down and migrate to Ivy completely. So why Ivy is going to be smaller? Usually when I'm discussing the bundle size in the context of a front-end framework, I'm talking about runtime, tree shakeability, and generated code. The runtime is the part of the framework that is responsible for rendering your applications, change detection, as well as dependency injection, and more. This
All right, we're almost back. I'm not saying anything this time.
I actually don't have any important visuals, so I can keep talking about the runtime. So the runtime of Ivy is, in fact, not going to be much different from the runtime of Vue Engine. So we're on par in this sense. Ivy and Vue Engine are pretty much the same size. But in terms of tree shakeability, Ivy is much more well suitable in order to make sure that you're getting rid of the pieces of the framework that you're no longer using. For example, if you're building an Angular element, or if you're building a, I have visuals in a little bit, so let me give it a try. If you're building an Angular library, or if you're building a small application will be able to tree shake Ivy pretty easily, so that we're going to get rid of all of the pieces of the framework that you're no longer using. In terms of generated code, all right, it is back here. It's going to be back there in a moment. In terms of generated code, Ivy is much more efficient compared to Vue Engine. As you saw, we are no longer generating these ngfactories. We're generating just a bunch of instructions that describe the structure of your template. It is very similar to incremental DOM. For each element on your page, we're going to generate 2 instructions for starting this element, ending this element, and a couple of instructions for its template. I see the actual things that I'm talking about. Yeah, so this is going to, this limited subset of code that we're going to generate for Ivy is, in fact, going to be between 0 and 70% smaller compared to Vue Engine. So for larger applications, you can expect dramatic improvements in terms of bundle size. Where you're probably not going to get huge improvements is the bundle size for medium applications, where you're using most of Angular, and you're also using, you also don't have that many templates, so that we're going to produce less code. Here is what I was talking about. On this chart here, you can see that the yellow bar is the size of your original template in your application. We have the red bar, which is the size of the source code generated by Ivy, and the blue one is the source code generated by Vue Engine. You can see that consistently, Vue Engine code is much bigger compared to Ivy. All right, and the last thing that I want to talk about today is internationalization. I have been talking to a lot of developers on different events who were unsatisfied with the internal serialization experience, mostly because their Angular.json in Angular CLI was growing a lot, and their build time was increasing for each new localization that they were adding. Currently, the internal serialization works the following way. We have your application library. We're passing a specific localization, doing some replacements of internal serialization markers, and from there, building your application for each individual localization. So if you have 5 different localizations, we'll build your application 5 different times. Of course, we were optimizing all the assets to the maximum, so you wouldn't have absolutely nothing, absolutely no runtime overhead once you build your application to a given localization, but still this was taking a lot of time to produce your production assets. With Ivy, we're changing this. We built new internal serialization pipeline, which is backwards compatible with the previous one. It is also built with runtime in mind. So now, once we build your application with ngCC, we're going to add some markers that we are going to replace with a specific localization after linking and optimization. This is going to allow much faster build times when you're using multiple different locales. I'm really happy to encourage you to try Ivy today, because this is something that we have been working on for a while, and I'm really happy with what it is going to bring to your applications. It is going to make your application smaller, faster, and it is going to enable a lot of new features. So please give Ivy a try today. Make sure that you file an issue or reach out to us on devrel@angular.io if you face any issues. In the Angular team, we often refer to Ivy as an enabler for faster applications, better development experience, simplification of Angular, making it more predictable, and so on and so forth. Being part of the Angular community for the past 7 years, I like to think of Angular as an enabler. I have seen hundreds of applications built from large financial institutions, large transportation companies, big media, and also a lot of startups, which are pretty much running the world right now. I also see a lot of developers, and most of them, I guess, are in this room today, who are building new tools for developers that are constantly improving our development experience. So I really cannot wait to see the future of that you're going to build on top of the APIs that we provide in Ivy. Thank you very much.